Hello everyone, I am your Deepak. I welcome you all to your YouTube channel Excellent Academy. In this session, I am going to solve the problems on HCF and LCM. So without wasting much of our time, let us go for this session. See, in your HCF and LCM, there are 7 common types of questions being asked in your exams. How many types? 7 common types. So let me explain those concepts before I start solving the problems. Okay, please observe here. The first is the type 1. Okay, type 1. See now, first you should know whether I am going to find HCF or LCM. Okay, so there are questions which make you confusion. Okay, so whether I need to find out HCF or LCM. Please observe now, type 1 now. Find the number which on dividing x comma y comma z leaves no remainder. Find the number which on dividing. So my number is going to divide your x. Okay, the number is going to divide your y also. The number is going to divide your z also. Okay, but there is no remainder. That means it is going to divide exactly without remainder. That is what no remainder means. It is completely divisible. Okay, now you mind, in your mind there may be some question. Sir, now I need to find out HCF or LCM. Please, my dear students, please listen this very carefully. If the number that I want, if it is in denominator, the number that I want, if it is in denominator, then you are finding HCF. The number that I want, if it is in denominator, then that is your HCF. Okay, now find the number which on dividing, when I divide the x by n, that number, it is divisible completely. Y is also completely divisible. Z is also completely divisible. Then what you need to find out? So what is your number? That means you have to find the HCF. HCF of what? HCF of x, y and z. So if you find HCF of x, y, z, then you are going to get that number. Okay. If the number is in your denominator, means you are finding what? HCF. You are finding HCF. See here. The number which on dividing, I am dividing the number. Okay. So I am dividing x by that number. I am dividing the number that y by that number, and I am dividing z by that number. When I divide all these things, it is exactly divisible. That means there is no remainder. Okay. Then the number that I want is in where? Denominator. That means what? I am finding the HCF. See, in this problem, for the first type, what you need to find out? HCF. HCF of what? HCF of x, y, z will give me the answer for that question. Okay. Now, the another type, type 2, please observe here. Find the number on dividing. Okay. So I am dividing x, I am dividing y, and I am dividing that number by the x, y, z by that number. Okay. That means what? So I am to find the number that I require is in where? It is in denominator. Therefore, what I am going to find out? Now I am going to find out HCF. So the confusion of HCF and LCM is eliminated. The number that I want, if it is in denominator, that means you have to find out HCF. Now, further you observe. Leaves same remainder in each case. In the previous example, there was no remainder. Okay. Now, if I am solving here, I am going to get the remainder R. Here also remainder is R. Here also remainder is R. That means same remainder. In the earlier example, type 1, there was no remainder. Here, there is remainder R. Okay, but remainder means same. Remainder is same here also same, here also same. But what you need to find out? HCF. Then how to solve such question? You need to find out HCF of x minus y, y minus z, and your z minus x. This will give you the answer for this type of question. Okay, if there is a same remainder in each case, so how to find out? HCF of x minus y, y minus z, and z minus x. This will be your solution for this kind of question, that is type 2. Okay, let me explain one more time. Please observe here. Find the number on dividing x comma y comma z leaves same remainder in each case. That means I am dividing the x by my number, I am dividing the y by n, and I am dividing the z by the number. Okay, but there is a not zero remainder is not there. Here the remainders are there, but the remainders are same in each case. Here also r is the remainder, here also r is the remainder, here also r is the remainder. Then the number that I want, where it is that number that I want is in denominator, that means I need to find out what? HCF. That means I am finding the HCF. Okay, now in the earliest type 1, I am finding HCF of XYZ because there was no remainder. But here same remainder are there. Then what you need to do? HCF of x minus y, comma y minus z and z minus x. Hope you have understood with the type 2. Okay, so I will go for the next type. Next type 3. Find the number which on dividing x, y, z leaves remainder p, q, r. Now see, different remainders are there respectively. See here, I am dividing x by my number, I am dividing the y by my number, I am dividing the z by my number. The number that I want is in denominator, that means I am finding HCF. Okay, but it is not HCF of XYZ, it is HCF of, see here, different remainders are there. Therefore, HCF of x minus p, p is the remainder, okay, with respect to x, correct? Therefore, and HCF of y minus q, because q is the remainder with respect to your y, and z minus r, This will be the solution for type 3. First you have to guess whether I am going to find out HCF or LCM. If the number that I want, if it is in the denominator, that means HCF. If there is no remainder, then directly you have to find out HCF of x, y, z. If there is remainder, same remainder, then x minus y, y minus z, z minus x. If the remainders are different, then HCF of x minus p, y minus q and z minus r, where p, q, r are the remainders with respect to x, y and z. So these are the 3 types in your HCF. Okay, hope you have understood. Now type 4. Okay, please observe now. So up to type 3, that is your HCF problems. From type 4 onwards, that is LCM problems. Now please observe. Find the number which is exactly divisible. So my number is exactly divisible by x, my number is exactly divisible by y, and my number is exactly divisible by z. Now please observe here. The number that I want is in denominator or numerator. The number that I require, that I want, is in the numerator. The number it requires, if it is in the numerator, that means you have to find out LCM. See, the number which is exactly divisible means what? Zero remainder, that is no remainder. Okay, then you have to find out LCM of x, y, z, because there is no remainder, right? The solution for this type of question is LCM of x, y, z. That's it. Okay, so hope you have understood with type 4. First you should see whether the number that I want, if it is in numerator or in denominator. If the number that I want, if it is in numerator, that means you are finding what? LCM. Okay, if there is no remainder, just you find out LCM of x, y, z, then you are going to get that number. Okay, I will go for the next type. Now, type 5. The number which when divided by your x, the number which when divided by y, the number which when divided by z. Okay, if when I divide, there will be a remainder p in each case. Here also remainder is p, here also remainder is p, here also remainder is p. Correct? Remainder is p in each case. Now the number that I want is where? It is in the numerator. That means I am going to find out LCM. I am going to find out what? LCM. Okay, this is LCM of x, y, z. But there is a remainder, right? In the previous case, in the type 4, there was no remainder. Therefore, directly LCM of x, y, z. But here there is a remainder p. Therefore, after finding your LCM, you have to add that remainder p for the LCM. Okay, so that will be your answer. If there is a single remainder, P in each case, then what you need to do? You have to find out the LCM of all the three and you have to add P for that. This will be the solution for your type 5. Okay. The next type. Find the number which when divided by x comma y comma z leaves remainder p comma q comma r respectively. Okay. Now I am dividing the number. Okay, I am dividing the number from your x, I am dividing the number from y, I am dividing the number from z. The number I want, it is in the numerator. That means I am going to find out what? LCM. See, this is how you can avoid confusion to check whether I have to find out HCF or LCM. Okay, I need to find out LCM. Now, but there are remainders are different. See, remainders is P, Q, R. Then what you need to find out? LCM of x minus P. Okay, then y minus q, then your z minus r. That is what you need to find out. Okay, because there are different remainders, right? Therefore, x minus p, y minus q, and z minus r. Where p is the remainder with respect to x, q is the remainder with respect to y, and r is the remainder with respect to z. Hope you have understood. Okay, I will go for the next example. Next type, last type in your type LCM. Find the number which when divided by, I am going to divide by number by your x, I am going to divide the number by y, I am going to divide the number by z. The number that I want, it is in numerator, that means I want to find out LCM. Okay. Leaves z as the remainder in each case. Leaves same remainder in each case. When I am dividing x comma y comma z, leaves same remainder in each case. So what you need to find out? Very simple. So your answer is what? LCM of same remainder in each case means what? X minus y comma y minus z and z minus x. This will be your answer. X minus y, y minus z and z minus x. Because it is remainders are what? Same in each case. So this will be your type 7. Hope you have understood. Okay. Please pause the video and you see all the type 7 up to from type 1 to type 7. Okay. So with this I am going to start the problems on your HCF and LCM. Now I will go for the first problem. Please here, observe here. Find the greatest number that will divide. So the number is going to divide your 43. Okay, that number is going to divide your 91. Okay, and the number is going to divide your 183. That means the number that I want, where it is in denominator, right? The number that I want, it is in the denominator. That means I am going to find out HCF. This is your first step to identify whether you are going to find out HCF or LCM. Now I need to find out HCF. Now see. So as to leave same remainder in each case. Same remainder in each case. What is the formula? HCF of x minus y, y minus z and z minus x. Do you remember? That is type 1. Type 1 now. Okay, now I need to find out your HCF of x. What is x? 43 and 91. So that means what? HCF of 91 minus 43. Then HCF of 183 minus 91 and 183 minus 43. So I need to find this. I need to find this now. Please observe now. 91 minus 43. 91 minus 43. How much? This will be 8. Okay. So this will be 4. So 91 minus 43 is 48. So this will be 48. Here. 183 minus 91. 3 minus 1 is 2. Okay. 18 minus 9 is 9. So this will be 92. This will be 92 and this will be what? 140. I need to find out HCF of 48, 92 and 140. So 48, 92, 140. 48, 92, 140. HCF of 48, 92 and 140. I need to find out HCF of this now. So I have already explained you the trick to find out your HCF in very easy way, correct? So I need to find out this now. Among all this, which is the lowest number? 48. Now you check from 48 whether you can divide these two. No. Therefore, what you have to do? Go for factorization. Okay. See here. This can be written as 2 2's 4. Okay. 2 4's. Now you check out whether this number is divisible by 24. This is divisible. Whether this is divisible whether 24 into 3 times. 4 3 is 12, 3 2 6 7. So this is not divisible, right? Okay, then 24 is not your HCF. Then I will go 2 ones, 2 12s now. Okay, now I am going to check now. So whether from 12 I can divide? No, from 140 I cannot divide. Therefore, you see 2 into 2 is what? 4. From 4 whether you can divide all this? Yes. So what is your HCF? HCF is 4. HCF is 4. I have already explained you how to find out HCF very quickly in my shortcut trick. Okay. So answer for this question is option A. Answer is option A. Okay. Hope you have understood. I will take the next problem. The HCF of two numbers is 23. They have given HCF of two numbers is 23 and the other two factors of their LCM are 13 and 14. Now I need to find out the larger of two numbers. Before explaining this problem, I will explain this problem with a simple example. Then I will apply that concept to this problem. Okay, now please hear. So if I want to find out the LCM of 8 and 12, please see what you need to do. 4 2s is 8, 4 3s is 12. Whether you can divide further? No. See here from which number I have divided both the numbers? 4. Further I cannot divide these two numbers from any one common number, right? Therefore HCF is what? HCF is 4. Then how to get the other two numbers now? Please here. 4 2s are 8, 4 3s are 12. Okay, now similarly with this concept I am going to solve this problem now. See, HCF means further I cannot, once I get the HCF for the remaining numbers, for the remaining factors I cannot take any common, correct? After finding HCF, for the remaining factors I cannot take common. So that means if I want the number, how to find out? The factor into HCF. See, HCF is 4 and the factor is 2, 4 2s are 8, I will get the number. HCF is 4 and the factor is 3, 4 3s are 12, I will get that number. Now similarly with this example I have made you to understand the concept. Now I am going to apply the concept for this problem now. The HCF of two numbers. See, I don't know the two numbers here, I will take X and Y. Okay, so their HCF is what? 23. Okay, now the two factors are, I am going to divide from 23, the one factor is 13, another factor is 14. Okay, whether you can divide further? No. 13 and 14 is, there is no common factor for these two. That means HCF is what? 23. Correct? In the previous example I will explain you. Now, what are the two numbers then? 23 into 13 is one number. 23 into 13 is one number. Another number is 23 into 14 is my another number. Now, what they are asking? The larger of these two numbers. 23 into 13 is the smaller number and 23 into 14 is the larger number. Correct? So, answer is 322, option C. Option C is my answer. See how quickly and accurately I solved this problem. Since I am explaining you all the concepts, it is taking time, correct? Without concept, if I do, how you can understand? Okay, so I will explain each and every problem with the concept and also with the shortcut trick. I will go for the next problem now. Now please observe here. Six bells commence tolling together. Okay, so commence tolling together. That means at the time of my observation, it is already tolling. See, commence tolling means there are 6 bells are there. When I observe the 6 bells, they are already tolling. That is the meaning of that. And they toll at the intervals of 2, 4, 6, 8, 10, 12. Okay, there are 6 bells. Let me the 6 bells is P, Q, okay, R, S, T, U, V. This bell toll after every 2 seconds. Okay, so this bell toll after every 4 seconds. This bell toll after every 6 seconds. Here 10 seconds, 12 seconds, 10 seconds and 12 seconds. Like this, these bells are tolling. Okay, now respectively they are given. In 30 minutes, how many times do they toll together? How many times do they toll together? That is what they have asked you. Okay, here I am going to explain the concept later I will apply that concept to this problem. First initially observe what is the concept. I will going to take two bells only to make you understand this problem. Okay, so let the two bells is P and Q. P is tolling every 2 minutes I will take. So 2 minutes, after 2 seconds it will toll. Toll means ringing. Okay, after 2 it will toll again at 4. After that it will toll at 6. After that it will toll at 8. Similarly, Q I am going to take, it is going to toll, that means ring. After 4 seconds I will take 4, after that 8, after that 12, okay, after that 16, okay, like that. Now please see here. These two bells will together toll at 4 seconds, correct? See, at the 4 second, these two bells together will toll. Okay, simultaneously they will toll. Again they will toll at the 8th second. Again they will toll at 8th second. Together, I am telling, together they are going to toll at 8th second. Okay, again that they are tolling at the 12th second. See, these are the multiples of your P, correct? These are the multiples. That is common multiples. Okay, now that means what I am finding? I am finding LCM, correct? I am finding what? LCM. Similarly here, they have given, okay, so what I found? LCM. Now, here they are given 6 tolls. Which are the 6 tolls? Okay, so each bell is tolling at 2, 4, 6, 8, 10 and 12 seconds respectively. Now what I need to find out? I need to find out LCM, correct? So how to find out LCM using my shortcut trick? I have explained you. Find the biggest number among all these, which is that 12. Okay, now you check out which is the remaining digits, remaining number should divide 12. 2 is going to divide 12, yes. 4 is going to divide by 12, yes. 6 is going to divide by 12, yes. But 8 and 10 is not going to divide by 12, correct? Okay, now, so what I need to do? Next, what is the multiple of 12? Okay, that will be exactly divisible by your 8 and 10. Definitely 16. 12 5 is what? 60. It is divisible by 8, correct? Whether it is divisible? No. 8, no. Then 120. Okay, now from 8 I can divide your, from 120 I can divide, sorry, from 8 I can divide 120, right? Yes, from 10 also I can divide your 120. The LCM of these, okay, is 120. How I found LCM? Very quickly you observe now. So what is the LCM? 120. So I suggest to watch my shortcut trick to find out HCF and LCM. If you are not finding the video, please feel free to message me in my WhatsApp. I will share the link. Okay. So the LCM for this numbers is what? 120. After every 120 seconds, these bells are going to toll together. After every 120 seconds, these bells are going to toll together. Therefore, what they are asking, in 30 minutes, how many times they toll together? 30 minutes. I will convert into seconds. So 30 into 60. Okay. So they toll together in how many seconds? 120 seconds, right? I will cancel this. Okay. Then 6 1s, 6 2s, 2 1s to 15. So in 30 minutes they toll 15 times. But initially only when I observed they are tolling together, right? See, in 30 minutes it will toll 15 times. But when I saw that all the 6 bells, they were already tolling. They have given 6 bells commence tolling. That means at the time of my observation only, they were tolling together. Okay, after my observation, they tolled 15 times. But initially only they were tolling. Therefore, totally how many times? They tolled totally 16 times. Therefore, answer is 16. Most of the students will make mistake by selecting option C. See, please see the question very carefully. They are given 6 bells commence tolling together. That means when I started the observation, when I started observing these 6 bells, they were already tolling. After that, they tolled 15 times. Totally how many times? 16 times. Therefore, answer is option D. Okay. See here, many students will commit mistakes by selecting option C. Okay. I will go for the next problem. Let n be the greatest number. N be the greatest number that will divide. So that will divide 1305. So 1305 is divided by n. 4665 is also I am going to divide by n. And 6905 is also divisible by n. Leaving the same remainder in each case. Leaving the same remainder in each case. First you see here. The number that I want is in denominator. The number that I want, where it is in the denominator. That means what I am finding? I am finding the HCF. I am finding the HCF. But it is going to give the same remainders. Same remainder. So what is the concept you have to apply? HCF of same remainder means what? Y minus x 4665 minus 1305. Then z minus y 6905 minus 4665. Then z minus x, that is 6905 minus 1305. Now I need to find this. Okay, first we find out the difference of these numbers. Okay. Difference is 3360. The difference of these two is 3360. Next, difference of these two, 2 and 4 0. The next, that is 6905 minus 1305. That is what? 5600. Okay. Now please observe. I need to find out HCF of 3360, 2240 and 5600. Initially what I will do is, in order to solve the problem very easily, okay, initially I will ignore the zeros. Okay, later I will consider. Initially I will ignore these zeros. Now what I need to find out? I need to find out HCF of 336, 224 and 560. I need to find out HCF of 336, 224 and 560. Now I will apply my shortcut method to find out the HCF. Among these, which is the least number? 224. Okay. Now you check from this number I can divide whether these two? No, I cannot divide. Now list out the factors of this 224. The factors of 224. 2 into 112, right? 2 into 112. Now you check out from 112 whether you can divide this. Yes, I can divide. 3 times it will go. 2 times. This is what? 5 times. So this number is divisible by 112. So therefore HCF of these 3 numbers is 112. HCF is 112. But I ignore the zeros in the beginning, right? Therefore I will consider 0 now. I will consider the 0 now. Okay. Now I got what is the HCF. What is the HCF? HCF is 1120. HCF is 1120. What the HCF is 1120. But in the question they are not asking the HCF. What they are asking is the sum of the digits. The sum of the digits. That N is HCF here, correct? The sum of the digits I want. See, sum of digits. 0 plus 2, 2 plus 1 is 3, 3 plus 1 is 4. Answer is what? Option A. What they are asking is sum of the digits in that HCF. So answer is what? Option A. Hope you have understood with this problem. If you are not getting, pause the video and watch it again. Okay. If you have any doubts, please feel free to ask me. I am going to explain you. Okay. So I will make another video to make you explain. To explain you, I will make any number of videos. No need to worry. Okay. I will go for the next example. The greatest number of 4 digits. The greatest number of 4 digits which is divisible by 15, 25, 40, 75. Now, I am dividing find the greatest number of 4 digits which is divisible by. I am dividing my number by 15. I am dividing number by 25. I am dividing the number by 40 and I am dividing the number by 75. Okay. Now, this is exactly divisible. The number that I want, where it is in the numerator, that means what? I am finding the LCM. What I am finding now? I am finding the LCM. So I want to find out the LCM of 15, 25, 40 and 75. I am finding LCM of 15, 25, 40 and 75. How to find out LCM using my shortcut technique? Find the largest number among all the numbers. Okay. So in order to further simplify this, first I can see that I can take 5 common. In all the things I can take 5 common. Otherwise you can straight away you can do also. Okay. So what is this? What is the shortcut technique now? You can take common or else directly you can do. Okay. From 15 you can divide 75. Okay, yes I can. Therefore I will ignore this. From 25 you can divide? Yes, I will ignore this. Then only I need to find out LCM of these two. Okay, so if it is divisible, you can ignore those numbers. I already explained in my shortcut technique. Now, among your 40 and 75, if I find out LCM, then will be the LCM of all the four numbers. See here, what I can take common? I can take 5 common. 5 8s are 40. Here, 5 15 times. Okay, now with your 5 and 18, what is your LCM for your 18 into 5? That is LCM is 120 into 5, that is 600. The LCM of 15, 25, 40, 75 is 600. But what they are asking, you see in the question, the greatest number of 4 digits they are asking. Now what I am getting is, it is the least 3-digit multiple. But what they are asking is, greatest 4-digit number of this multiple they are asking. Okay, that means they are asking the multiple of 600. Okay, multiple of 600, which is greatest 4 digit. I know what is the greatest 4 digit. What is the greatest 4 digit? 9999. Okay, now you divide this from 600. 600 once is 600. What is left out? 99. Okay, take one 9 here. 600 once is again 600. What is left out? 399 is left out. That means I cannot further divide this, correct? So that means this is the remainder. Okay, so 9999 is not completely exactly divisible by 600. When it will become exactly divisible? When I subtract 399 from it. When I subtract 399 from it. So what is your answer? 9600. So that is the largest 4-digit number which is multiple of 600 is 9600. Option number C. Option C. See what they are asking. The greatest number of 4 digits which is divisible by, see if 600 is divisible by all this number, its multiples are also divisible by all this number, correct? See, 1200 is also divisible, 1800 is also divisible. Like that, what they are asking you is, they are asking the largest largest number of 4 digits, okay, which is exactly divisible by your LCM. Okay, now see, so this is what I did. So answer is 9600. Hope you have understood with this example. The next question, what they are asking, the product of two numbers is 4107. The product of two numbers is 4107. If the HCF of these two numbers is 37, then I need to find out the greatest number. Okay, now if there are two numbers and HCF is 37, means what? See, what is the maximum common thing I can take from these two numbers is 37. Okay, that is the meaning of HCF. So I will take the two numbers as 37x and 37y. See, what you can take common? The maximum I can take common is 37. So what is the maximum you can have taken common means that is your HCF, because they have clearly given what is your HCF. If you take 37 common, what is left out? X and y. So that means, so these two numbers are 37x and 37y. The two numbers are 37x and 37y. The product of these two numbers they have given. What is their product? That is 4107. Okay. Now, I need to find out the greatest number among these two. Hope you have understood up to this. Okay, now, I will simplify this. 37 1 times is 37. What is left out? 4 left out. 37 1 times is 37. 3 left out. 37 1 times is 37. Okay, again I can do 37 3 times is 111. Therefore, x into y is equal to what? 3. X into y is equal to 3. Now please observe here. If you take HCF common, the remaining factors are always co-prime. The remaining factors are always co-prime. See, I will explain with a simple example here. See here. Okay. Now, I will take 4 and 12. Now, 4 1s are 4, 4 3s are 12. HCF is what among these two? 4. Then the remaining factors after you find out HCF are always co-prime. That means what is the maximum thing you can take common? One only you can take common. Other thing you cannot take common. That is nothing but co-prime. Another example I will give. Please observe. 5 and 35. See here. 5 1s are 5 7s are. What is your HCF? HCF is 5. Okay. If you take HCF, okay, the remaining factors are always co-prime, because what is the maximum thing I can take common? 1. So that means the remaining left out factors after your HCF is taken, okay, then they are co-prime. Now I have already taken my HCF, okay, because I have simplified, right? From your HCF I have simplified. Then these two are always co-prime. So co-prime numbers is if x is equal to 1, y is equal to what? 3, or x is equal to 3, y will become 1. So they are not asking the value of x and y, they are asking the greatest number. Okay, so one number is 37 into x, that is 37, but I want greater number, bigger number, that is 37 into y. 37 3 times. What is 37 3 times? Is 111. Answer is 111. Option C. Answer for this question is option C. Hope you have understood with this example. I will go for the next example, next problem. See, I have shortcuts for each and every problem. Okay, no need to worry. Don't go your lengthy procedure. If you follow the lengthy procedure in examination, you cannot solve many problems. Okay, see my shortcut tricks. Okay, then you can solve the problems very quickly. Next problem. 3 numbers are in the ratio 3:4:5. Their LCM they have given 2400. I need to find the HCF. See, the 3 numbers are 3x, 4x and 5x. 3x, 4x and 5x. Now, from which number I can divide all this? From x I am going to divide. Okay, x 3 times, x 4 times, x 5 times. See, 3x, 4x, 5x. See, these are what? Further, there is any common, from common number I can divide all this? No. There is no common number. Again I can divide all these 3 numbers. That means HCF, I found out what is the HCF is x. Okay. Now, what they have given? They have given the LCM. What is LCM of these 3 numbers? See, 5 4s are 20, 23 is 60, 60 into x. LCM is 60x. LCM is 60x. Okay, the LCM they have given. What is your 60x? See, they have given the LCM, that is 2400. I will simplify this. 6 4 6 24. X is equal to what? 40. What is my HCF? HCF is x, that is 40. The answer for this question is option A. See how quickly I did, only through applying the concept. So if you understand the concept, you can do any problem. Okay, what I suggest you, before you solving any problem, understand the concept. Understanding the concept, only you can solve any problem. Okay, so answer for this question is option A. I will go for the next example, next problem. The GCD, that means HCF. What do you mean by GCD? HCF, greatest common factor or HCF. See, now they have given the decimal numbers. They have given the decimal numbers. So no need to worry. So they have given 1.08, 0.36 and your 0.9. So for this they are asking HCF. Don't worry, I will give the trick now to find it very quickly. Okay, please hear. I will make a whole number all this. So in order to make whole numbers, see here, after decimal point there are 2 digits. Okay, so maximum there are 2 digits after the decimal point. Therefore I will multiply all the numbers by 100. So this will become 108, this will become 36 and this will become what? 90. Now how to find out HCF using my shortcut trick? So how to find out HCF? Find the least number. Find the least number among all this. What is that? 36. Now you check out from 36 whether you can divide 108 and 90. No, not possible. Okay, then factors 2 and 2 and what? 18. Okay, now we check whether you can divide all the 3 numbers from 18. Yes, you can divide. See, 18 6 times is 108, correct? Now 18 2 times, 18 5 times. Therefore, what is your HCF? HCF is 18. But what I have done? I have multiplied by 100. Okay, that is a small trick I used. But I don't want to multiply because the decimals are the decimal numbers, right? So instead of there I have multiplied by 100. Therefore now I will divide by 100. So answer is what? 0.18. See, that is how you can do. If you multiply by 100, and finally you have to divide by 100. The answer for this question is 0.18, option C. See how to find out HCF and LCM if they have given decimal points. So you have to multiply by the number, later you divide that by number. So option is option C. Hope you have understood. Now next question. The product of two numbers is 2028. Okay, the product of two numbers is 2028 and their HCF. If they are given HCF means I am going to take the two numbers as 13x and 13y. Okay. The product of these two numbers they have given 2028. Okay. Now for such kind of numbers, how many pairs of numbers exist? What they are saying? The product of two numbers is 2028. Their HCF they have given 13. Now, if I get the product as 2028, how many numbers are there which is going to give this product they are asking? Okay, now please observe here. Now, 13, one time is 13. Okay, what is left out? 7. 13 5 is 65. Okay, what is left out? 7. 13 6 is 78. Now, again I will divide. 13 1s are 13 two times. So x into y is what? 12. X into y is 12. Now after taking your HCF and if you have solved, then remaining two numbers are always what? Co-prime number. Please observe here. I will give an example. 24 and 36. Now you see. 12 2s are 12 3s are correct. So that means I have taken the HCF common. See, after taking HCF and simplified, that means HCF is over. The remaining factors are always what? Co-prime, correct? That means there are further I cannot take anything common apart from 1. Similarly, in this example, I have simplified with the HCF. Then these two are what? Co-prime. What do you mean by co-prime? HCF should be 1 between them. You have to pick such numbers now. See, 1 into 12. 1 into 12 is what? 12. Then 2 into 6 you don't pick because for 2 and 6 HCF is not 1. Okay, HCF is not 1. You have to pick co-prime numbers only. Next number 4 into 3. Okay, is also 12. Say how many pairs exist? Only 2 pairs. 3 into 4 is nothing but 4 into 3. Don't again take. Okay, so how many pairs exist now? Only 2 pairs. See, HCF is 4 and 3. HCF is what? 1. Here also 1. You have to pick such pairs only. Therefore, answer is what? Answer is 2 pairs, option B. Option B. The next problem. The least multiple of 7. Okay. Which leaves remainder 4. When it is going to leave remainder 4? When it is divisible. When it is divisible. When I come to divide by 6, 9, 15 and 18. Okay, when I divide the number by 6, 9, 15 and 18, I am going to get the remainder as 4 and they have also told this n is a multiple of your 7. That n is multiple of 7. Now please observe, first of all, the number that I want is in the numerator. That means what I need to find out? That means I need to find out the LCM. First of all, you eliminate the confusion in your mind whether I need to find out HCF or LCM. The number I want in the numerator. That means I need to find out the LCM of 6, 9, 15 and your 18. Okay, first, how to find out LCM? Observe the biggest number among all these 18. From 6 whether you can divide? Yes. Therefore, you ignore this. From 9 you can divide. From 18 whether you can divide from 9? Yes. Okay. Then what left out is what? 15 and 18. From 15 I cannot divide. Therefore, you tell the multiple of 18 which you can divide from 15. Okay. 15 5 times. 90, right? 15 5 times is 90. From your 15 I can divide. Therefore, LCM is what? 90. See how quickly I am going to tell my LCM. Okay, what is the LCM of all these numbers is 90. But what they are asking is, okay, they should give remainder 4. Remainder I should get 4. But this is an multiple of 7. That should be multiple of 7. That should be multiple of 7. 94 is not a multiple of 7 because it is not completely divisible by 9, correct? So now I have to find out the multiple of 7. Okay, so for this number now, see, and every time you should leave remainder 4 when you divide from this number. So how to find out? Now 90 into k plus 4 should be divisible by 7. Such number I want. In the numerator what they are asking is, it should be multiple of 7 only. Okay, now 94, if k is equal to 94, 94 is not a multiple, correct? Now among the option, see, if already it is 90 plus 4, 74 cannot be your answer, 94 is not your answer. Then 184 is a multiple of your 4, 7 check out, 7 2s are 14, 4 left out 44, no, this is not a multiple. Then your 364, yes, it is a multiple definitely. See, if k is equal to 4, that will be 360 plus 4, definitely it is divisible. Therefore option D. Option D. Now if you divide 94 from all these, remainder is 4. If you divide 364 from all these, remainder is also 4. What they are asking, in the numerator I want multiple of 7. That should be, multiple of 7 means what? That is completely divisible by 7. But if you divide from these numbers, remainder should be 4. When you divide from these numbers, remainder should be 4, but it should be multiple of 7. That means when you divide by 7, it is completely divisible. Such number they are asking. What should be your answer? 364. The least number which should be added to, 2497. Okay. So initially it is not completely divisible. If I add something, then only it will divisible by your 5, 6, 4 and 3. See, divisible by 5, 6, 4, 3. Initially they are not divisible. They are telling the least number which should be added. If I add something, then only it is divisible. Okay. Now, the number that I want is in where? It is in the numerator. That means I need to find out the LCM. LCM of 5, 3, okay, 4, 5 and 6. 3, 4, 5, 6. Among all this, which is the biggest number? 6. Now, from 3 I can divide. Yes, therefore ignore 6. Ignore 3. Then 4, 5, 6 is left out. Okay. From 4 and 5 I cannot divide over 6. Then multiple of 6, okay, which is divisible by 4 and 5, which is that 60. Okay, multiple is 60. Therefore LCM is, from 4 also I can divide over 60. 5 can also I can divide. Therefore LCM is 60. Okay. Now, if you divide the number 2497 from your 60, okay, this is not completely divisible. But if I add something, then it will be completely divisible. Let me check out what I have to add now. 4 times is what? 24. Therefore 240. Then 97 is left out. 61 times is 60. 37 is left out. Now, instead of 37 here, if I add 60, 61 times is 60, again I can divide. But it is not 60. It is less. It is less by what? It is less by 23. Okay. If I add 23, this will become 60, I can divide. So therefore what should be added? 23 should be added. Therefore what is your answer? Option C. That's it. Very simple problem. Only understanding the logic and applying the shortcut, I can solve any problem in the less than 15 to 10 seconds. Okay. That's it. Next question. The least number which when divided by 5, 6, 7, 8 leaves a remainder 3. Okay. The least number which when divided by, when I am going to divide the number by 5, 6, 7, 8, okay, leaves remainder 3. What is the remainder? 3. But when it is divided by 9, if instead of all these numbers, if I divide by 9, no remainder, that means it is exactly divisible. Okay, now first let me find out this n now. Okay, so now please observe here. The number that I want is in numerator. That means I want to find out the LCM. And this remainder means after finding LCM, we have to add that remainder for that. Correct? Now please see here. 5, 6, 7, 8. Which is the biggest number among all this? 8. Okay. Now please observe here. 5 and 7 are what? 5 and 7 are prime numbers. Therefore in my LCM 5 and 7 should be there. Now 6 and 8. Okay, what is a multiple of 8 which is divisible by 6? 24, right? For your 8 and 6, 8 3 is 24, from 6 you can divide. Therefore LCM for these two is 24. Now my LCM I have to find out now. 7 5 is 35. 35 into 24. I need to find out. Now for multiplication, I will apply the Vedic mathematics. 35 into 24. 35 into 24. My Vedic trick. 5 4 is 22 carry. 4 3 is 12. 12 plus 10. is 22 plus 2 24, 2 carry, 3 2 6, 6 plus 2 8. 840 is the LCM. Okay, what is LCM? 840. But see, it should leave remainder 3 in each case. Therefore, what should be our answer? 840 plus 3. 840 plus 3. 840 plus 3. 840 is completely divisible by all this number, but I want remainder as 3. Therefore, 840 plus 3. Now, what they are telling, 840 plus 3, if you divide from, okay, if you divide from 5, 6, 7 and 8, it is going to give remainder as 3. But if you divide from 9, there should not be any remainder. Okay, now I will consider this as k. Now put any value for k so that it is divisible by 9 exactly. Put k is equal to 1. So if you put, it will be what? 483. 483 is not divisible by 9. Put k is equal to 2. Okay, if k is equal to 2, that will be what? 2 8, 2 16 plus 3, that is 1683 divisible by 9. Check out whether you can divide. 9 ones is 9. Okay, that is 7 left out. Then 8 nines are 72, 6 left out. 7 9 sevens are. So I can divide, right? So what should be your answer? 1683. Option B. 1683. 1683. Option B. So what you need to do is, first you find the LCM. Okay. So if you find the LCM, then it is completely divisible. But I want remainder as 3. Therefore add that remainder. But I want that it should be multiple of 9. Okay. So that means because it should be completely divisible by 9. Okay. Therefore you have to pick that answer among the option. What is your answer? 1683. That's it. Next question. A comma B and C, A, B and C start at same time in same direction to run around a circular stadium. Okay, there are 3 persons here. See, from this point they are going to start running. Who are that? A, B, C. Okay, they will start running here from the same point and in same direction. A completes a round. That means in one round A is going to take only 22 seconds and B is taking 30 seconds and C is taking 18 seconds. Okay, all starting at the same point. This is the point. After at what time they will be at the starting point. After what time will they be again at the starting point? They are asking. Now please observe here. I will give one simple example to make you understand. Later I will solve this problem. Okay, I will consider A and B now. See, A is going to take 2 seconds to complete one round. B is going to take 3 seconds. Let me assume that. Okay, now after 2 seconds he is going to make one round. After 4 seconds he is going to make second round. After 6 seconds he is going to make the third round. Okay, after again 8 seconds, after 10 seconds, after 12 seconds, similarly. B is going to take 3 seconds, right, to make one round. Similarly here 3, 6, 9, 12, 15, 18, so on. See, again they meet at the starting point. Okay, so after 6 seconds, because common multiple is what? After 6 seconds. Again they will meet after 12 seconds. Okay, again 18 seconds. That means what? I am finding the least common multiple in order to check again when they are going to meet, correct? Similarly, here I am going to take, instead of 2 and 3, I have taken 22, 30 and 18. Okay, what I am going to find out? I am going to find out the LCM now. What I need to find out? LCM. Now, which is the biggest number among here? 30 is the biggest number. Now you check whether it is divisible by these two. No. So what I will do? I will simplify this. First I will take 2 common, 2 11s, here 2 15s, here 2 9s. Okay, now I need to find out the LCM for this. Here 11 is a prime number, therefore 2 into 11 into, for your 15 and 9. Okay, so what is the bigger number among these two? 15. Okay, which is the multiple of 15, which is exactly divisible by 9? 45. 15 3 is 45 and 9 5 is 45. Okay, so 45 is here. Now LCM is what? 22 into 45. 11 into 2 is what? 22. 45 into 22 is your LCM. Okay, so this is 5 to 10, 11 is a carry forward. Okay, so 22 5 times is 110, right? 22 5 times, you check out 10, 110. Then 22 4 times is 88. 88 plus 11 is 99. See, they will meet, all three people will meet after 990 seconds. After 990 seconds they will meet. After 990 seconds they will meet. After 990 seconds. Okay, now, but what they are putting the options in terms of minutes and seconds, correct? 16 minutes, 30 seconds, like that. So, let me convert this in terms of minutes now. How to convert into minutes? Divide by 60. Okay, 6 ones are 6. Okay, 3 left out. 6 6 are 36. 3 left out. 6 5s are. That means 16 minutes, 16.5 minutes. 16.5 minutes. That is nothing but 16 minutes, 0.5 minutes, nothing but 30 seconds. 16 minutes, 30 seconds is your answer. Option A. 16 minutes, 30 seconds. Hope you have understood. Okay, so we'll go for the next problem. See, for every problem, I have a shortcut. With that shortcut, I can solve any problem in less than 10 seconds to 15 seconds I can solve. Okay, now next problem. Since I am explaining you, I am taking a little bit more time. If I solve any problem, I will solve in 15 seconds. Now next problem. The HCF of two numbers is 11. The HCF of two numbers is 11. And their LCM is 7700. If one of the number is 275 and we have to find out the another number. Please note that, kindly note that HCF into LCM of two numbers is equal to the product of two numbers. The product of two numbers is always equal to the product of their HCF and LCM. Write it down in your notebook. The product of the two numbers is always equal to their product of HCF and LCM. Their HCF and LCM. Okay. Now, the HCF of two numbers is 11. That means the two numbers I am going to take it as 11x and 11y. Okay. Their LCM they have given. See, the two numbers are 11x and 11y. The product of two numbers is equal to their HCF multiplied by their LCM. Okay, I know this. Correct? Now, they have already given the LCM. What is your LCM? 7700. Okay. Now, HCF also they have given. What is the HCF they have given? 11. Now, one of the number they have given. One of the number also they have given. So, among these two, you take one number. So, 11x, I will consider that is 275. Okay, into 11y. So, I need to find out the another number. What is your another number? 11y is another number. Correct? Now, I need to find out this. So, here, I will simplify this. 25. 1 times is 25. Okay, 2 left out. 25, 1 times is 25. Here. Here. 25, 3 times is what? 75. 2 left out. Okay. Then 0, 8. 308. Now, from your 11. 11, 2s are 22. Okay, 8, 11, 8s are. So, 11y is equal to 28 into 11. What I want? 11y. Another number is what? Another number is 11y. So don't solve here. 11y, let it be like that. See 8. This is 10. Okay. Then this is 3. Another number is 308. Another number is 308. See how quickly I did. So answer for this question is 308. Option C. Option C. See, I have to explain you. Okay. So I am taking time. If not, I will calculate many things in my mind only. You can also become like this only through practice and understanding the logic and also applying the shortcut methods. Okay. Next problem. What will be the least number which when doubled, it is exactly divisible by 12, 18, 21 and 30. Okay. So let the number be x. The number is not divisible. But if you double it, let it the number is h. If you double it, then only it is divisible. From which numbers it is divisible? It is divisible by 12, exactly, it is divisible by 18, then it is divisible by 21 and it is also divisible by 30. It will be divisible only if you double this. Okay, then what they are asking? They are asking that number. That means x they are asking. X is not completely divisible. If you double it, then it will be completely divisible. The number that I want is in the numerator, right? That means what I am finding? That means I am finding the LCM. LCM for your 12, 18, 21 and your 30. Okay. Now here which is the biggest? Now I can take 3 common here to make it simplify. I will take 3 common. 3 4s are 12. 3 6 are 18, 3 7 are 21 and 3 10 times. Okay, now here 7 is the prime number, therefore I put it outside. 3 into 7. Now left out is 4, 6 and 10. Okay, now which is the multiple of 10 which is divisible by 4 and 6? 20, no, 30, no, 60 I think. No, 48. Oh, 60 only, correct? Multiple of 6, 10. See, from 4 also I can divide, from 6 also I can divide. So for what is LCM here? 60. Therefore your total LCM will be 3 into 7 into 60. So this will be 21 into 60 is your LCM. 21 into 60. 2x is nothing but 21 into 60. So that is 1620. But what I want not the double of that number, I want that number. So how to find out that number? X I want, divide by 2. So that number is 630, option B. What they are asking, they are not asking the double of that number, they are asking that number x. 2x is equal to 1260 means x is equal to what? 630, that's it. Hope you have understood with this example. I will go for the next example now, next problem. The ratio of two numbers is, they have given two numbers, their ratio is 3:4 and their HCF is 4. Let the two numbers ratio they have given, right? So two numbers is 3x and 4x. Okay. Now I will find the HCF here. X 3 times, x 4 times. Whether you can further divide? No. From which number, a common number you have divided? From x. Further if you cannot divide means x is your HCF. What is your x? Is nothing but HCF. They have given that HCF, that is 4. X is equal to 4. Then I need to find out what? LCM. What is your LCM here? See here LCM is 4 3s are 12, 12 into x. 12x is your LCM. What is your x? 4. 12 4s are 48. Answer D. See how quickly I did? Only through applying the concept. That's it. So answer is option D. See, the two numbers they have in the ratio 3:4. That means two numbers are 3x and 4x. From which number I can divide? These two numbers can be divisible by 3x. X 3 times, x 4 times. Further I cannot divide because these two are co-prime. So that means x is the common factor for both two. That means HCF is 4. Because they have given HCF is 4. Okay, what is the LCM now? 4 3s are 12. 12x is your LCM. 12x is nothing but 48. That's it. Now, the last problem of this session, the smallest number which when diminished means subtracted, okay, by 7, then it will be divisible. See here, initially it is not completely divisible, okay. If you subtract 7 from it, then it will become divisible. If you subtract 7, then it will become divisible, okay. So x minus 7 you do, then it is divisible by 12, it is divisible by 16, it is divisible by 18 and 21. Okay, if you don't subtract, it is not divisible. That means it is going to give 7 remainder. Okay, that is the meaning. Now I need to find out that the smallest number. Okay, so I need to find out that number. Okay, let me consider this numerator as n. Let it be n. Okay, now. So the number that I want is in the numerator, right? So I need to find out the LCM. So LCM of 12, 16, 18 and 21. LCM of 12, 16, 18 and 21. I will apply prime factorization method now to find out the LCM. What do you mean by 12? 12 is nothing but 2 into 2 into 3, right? It is 2 square into 3. 2 square is 4, 4 3 is 12. I will apply prime factorization method now. 2 power 4 is 16. Here 2 into 9, 9 is nothing but 2 into 3 square. Here 7 3 is 3 into 7. Now how to find out LCM using prime factorization method? Please observe. Write all the numbers whatever you have. I have 2, I have 3, I have 7. See, write all the numbers whatever you have here. 2 I have, 3 I have, 7 I have. Now, you have to consider the highest powers of that particular number. For your 2, what is the highest power? 4. 2 power 4. For your 3, which is the highest power? Square. For your 7, 1 only. Okay. Now, my LCM is 2 power 4 is 16, right? 3 square is 9 into 7. 16 9 is 144 into 7. 1008. So now I got, see what I got is x minus 7. What is x minus 7? 1008. Now I got what is the x minus 7. X minus 7 is
1008. But I want n, right? That means I want x. So x is what? 1008 plus 7, that will be 1115. So what I want? X I want. Okay. X I want. What is your x? X is 1015, not 1008. X minus 8 I got, but I want x. X is what? 1015. So option B. Option B is your answer.
With this, I am ending this session. If you have any doubts, please feel free to ask me. My WhatsApp number 9742331968. 9742331968. After this COVID pandemics, I am going to meet you all. I am going to explain each and every problem more better. Okay. So until then, you watch my videos. If you have not subscribed my channel, subscribe right now. Don't forget to click on the bell button for the updates. If you like my videos, like them and share them. Thank you.